Alright, let's look at the homework 2.2, problem number 4. We want to find the derivative of this following function g of x, which is square root of 6 minus x. Alright, so let's do that. Alright, so we're going to have to use the definition, so it's going to be limit as h approaches 0, right? Then g of x plus h, so we have to replace x by x plus h. So we have a square root of 6 minus x plus h, right? Minus f of x, which is just the original function, g of x, I should say, square root of 6 minus x, and all over h, right? And you can see that as h approaches 0, denominator obviously goes to 0, and the numerator also goes to 0 because h disappears. So you have a square root of 6 minus x minus itself. So the numerator here also approaches 0, right? So we're going to have to do something about this. So what we can do is we're going to do the trick we've seen quite a few times. We're going to multiply top and bottom the same thing, almost the numerator except for the sign. So we have a square root of 6 minus, I'm going to go ahead and write x minus h, just to distribute the negative sign to x and h, and a plus square root of 6 minus x, and I just do the same thing to the denominator so that we don't change the quantity, right? Right, so we have that, right? And this simplifies to limit as h approaches 0. Right, so multiply out, so it's a minus b times a plus b deal, so a squared, so just take the square root out. So it's a 6 minus x minus h minus b squared, so take the square root out, so it's going to be 6 minus x, right? Then all over, right, h is still there, and we can't really do too much, so I'll just write it down. So square root of 6 minus x minus h plus square root of 6 minus x, right? Then we're going to try to simplify as much as we can. So we have a 6 minus 6 cancel out, negative x minus negative x cancel out. So you have a negative h left. So, and we can cancel h and h here, so it's going to have a negative 1 left on top because there's a negative sign there. All right, then we are sending h to 0, so we know that this guy is going to disappear. So, all right, so therefore we have this formula, right? You have negative 1 on top, all right, then you have square root of 6 minus x, and you have another square root of 6 minus x. So you have a 2 times square root of 6 minus x, right? So that's the derivative, right? Then we want to, let's see, find the domain of the original function. So original function is a square root function, and we have to make sure that the expression inside is non-negative, right? So that will give us the equation 6 minus x is greater than or equal to 0, right? Then we can simply add x to both sides to isolate x. So 6 is greater than or equal to x, right? So the domain is going to be, so domain of g is, looks like negative infinity all the way to 6, including 6, right? Then look at the derivative. Right, derivative is slightly different because now square root is on the bottom. So to make this sense, we have to at least meet the domain of original function. But on top of that, Remember that when you have a fraction quotient, the denominator is not equal to 0. Alright, so let's do that. So you have a 2, and square root of 6 minus x cannot be equal to 0. Right, so you can divide through by 2. 2. Then you get square root of 6 minus x cannot be equal to 0. Right, and then we can square both sides. So 6 minus x cannot be equal to 0. Right, then you can just add this x to both sides. So 6 cannot be equal to x. So x cannot be equal to 6. So we have to eliminate 6 from this domain. So domain of g prime is negative infinity all the way to 6, but excluding 6. All right, so let's type those guys in. All right, so what we found was, let's see, it's a fraction, maybe I'll click that, and the negative 1, and I go downstairs, and 2 times square root of 6 minus x, right? So that was the derivative, and domain was from negative infinity to 6 with the square bracket, right? And this one, same thing with negative infinity and to 6 with the parentheses, right? So let's go down and submit for testing. All right, it came back and looks like we got all these guys correctly. All right, that's it. I hope that this was clear.